Good morning. My name is Marita Kotze. I am the Senior Education Specialist for Physical Sciences and Agricultural Sciences at Impact. So welcome to this session. I'm just going to wait a minute or two for all the attendees to logging in. So a very welcome to you. And while we are waiting, the PowerPoint, or you can see it as or a handout, and you can find it on the right or below on your computer screen. Make sure you can hear me. So yes, I'm just going to wait a minute. I can see there are still learners logging in. Okay. Okay, I'm going to start the session now. Good morning, very welcome to the session this morning. Right, my name is Marita Kotze. I'm the Senior Education Specialist for Physical Sciences. And before we begin this online class, let's cover some of the basics. If you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining the session. And should you have any questions during the session, you can write your question to the right or below in the question box. Make sure that you write all your questions that you do have to the right or below on your dashboard. Okay, I'm not going to deal with any questions during this session, so it's very important that you write all your questions in the question box. Download this presentation in the handout box below or on your right. So make sure that you do have the presentation in PDF afterwards. You can also use this then as notes. So make sure that you download today's presentation. And remember to send us your questions. If you do have any questions, you can send through questions to info@impact.co.za or to academics@impact.co.za. You can also visit Impact's website for the recordings of the session at the link https www.impact.co.za, and you click on COVID-19 online schooling past class videos. So make sure that if you still want to look at the session afterwards, that you download it from or look at it on our Impact's website. All right. What I'm going to do today is I'm going to start with your term 3 work, because I know you're busy preparing for the June exam that you're going to write, but it's very important that you start with your term 3 work, or else you will not be able to do all of it during the year. So please, during your revision, start doing your term 3 work. All right. Now, your knowledge area in term 3 is mechanics, scalars and vectors and movement in one dimension. This is the physics part that you're going to do in term 3. So what is scalars and vectors? If we look at this picture, we will see that we have weight, and we have mass, right? So when we look at the amount of matter that a body consists of, it is mass. So when you want to weigh yourself, and you weigh yourself on a scale and it's maybe 50 or 75 kilograms, then you will know that that is the amount of matter and that is your mass, right? But the moment when we talk about the attraction force of the amount of matter to the earth, you will see your vector is 1,500 newtons. So the mass, can you see there's no direction, there's only the number and the unit. So that's your mass, and the moment when we apply direction to it, it is a vector. Okay, so what are the topics that you are going to cover in scalars and vectors? I'm just going to do some introduction on scalars and vectors, the difference between the two of them, the direction of the vector, the graphical representation of a vector, the net or resultant vector, and addition of vectors. All right, so what is the difference between scalars and vectors? What are the differences? All right, so all physical quantities can be measured and divided in two groups. So you must, this is the basics of physics. So this is very important for your grade 10, 11, and 12 work. So make sure that you do understand the difference between the two of them, and you do understand how to apply this knowledge to your physics part for grade 10, 11, and 12. So this is not something you're just going to learn in grade 10. You're going to apply this knowledge in grade 11 and 12 as well. So make sure that you do understand this. And if you have any questions regarding scalars and vectors, you can send me an email. So let us look at scalars first. There's no direction. So you will only have a physical quantity that has magnitude. For example, mass. This car that you have here has a mass of 2,000 kilograms. So other scalars that we do have is distance. So when you walk from your house to school or to a friend, that's your distance. Speed, you're driving your bicycle around the neighborhood, especially now during lockdown, if you can do that the last month. So that is speed because you're changing direction all the time. You do it in a certain time. Work is done because it's movement over a distance, and temperature is also a scalar. Now let us look then at vectors. What's the difference then? A vector is the moment when we apply direction. Then you know it is a vector. A vector can be represented with an arrow, with an arrowhead that indicating the direction of the vector, as you can see here. And there will always be a direction. So you will have an angle at which you do this specific or have this vector. All right. So there you have the same car. It's his mass, and we apply the direction downward. So direction downward is the moment when we apply gravitational force. You will see that is your weight. So distance, the moment when we have a direction to it, it's displacement, speed, direction is velocity, acceleration in a certain direction, force and momentum. Now, force and momentum are two terms that you will learn in grade 11 and 12. So let us just have a look at scalars, the scalars and vectors. So the moment we applied with the units, you will see distance is 60 meters. So the moment when there's direction, it will be 40 meters west or 60 meters west. Speed is 60 meters per second. The SI unit, I use all the SI units in this table. So the SI unit for distance is meter. For speed is meters per second, mass is kilograms, time is second, wavelength is meter, energy is joule, power is watt, temperature is Kelvin. We also, you know that we measure temperature sometimes in degrees Celsius. That is the common name for you, but when we use the SI unit, it's Kelvin, and electric current is in amperes. So at the moment we have the speed and we say we have a direction to it, direction of 30 degrees, then it's a vector. Weight is downwards, and it's you can see 50 kilograms will be 490 newtons downwards, because you multiply your mass with your gravitational acceleration constant, and therefore your weight will be 490 newton. Make sure that you do understand you will still have the same amount of matter. Your mass will be the same. It's just where the pulling force down to the earth is then you multiplied with that, so therefore it's 490 newton. Acceleration is 5 meters per second, for example, is 470 newtons downwards. Momentum is 50 kilogram meters per second west, and impulse is 6 newtons. Right. So therefore, that are the scalars and vectors examples that it's just a few of them. All right, with the SI units. All right. So what do we have here? Scalar is a physical quantity that has only a magnitude and a unit. Vector is a physical quantity with a magnet, unit, and direction. And resultant is a single vector that will have the same effect as the original vector taken together. That I'm going to explain on the next slides. So that are the difference between the three of them, and it is their definition. So let us just see the direction of a vector. There are three different ways to represent the direction of a vector quantity. The first one is a compass. Right. Most of you are familiar with the compass. So let us just look at a compass. We have a north and a south, and north, east, south, west. So east, south, and west. All right. So if we have a vector, so for example, you are moving in a certain direction, and the direction is 30 degrees north of east, your velocity will be in a 30 degrees north of east direction, and your direction will be 30 degrees north of east. So that's the angle and the direction. All right. So the next one, for example, velocity 2 is 30 degrees east of south. So then your angle will be east of south. Okay, so 30 degrees east of south, your direction of a vector. The next way you can do that, bearings. This is used in the navigation of planes and ships. North is given the value of a bearing of 0 degrees. East is 90 degrees. South is 180 degrees. And west is 270 degrees. So let us have a look. North is 0 degrees, east is 90 degrees, south is 180 degrees, west is 270 degrees. So again, if we have the same velocity, you will see the bearing is 60 degrees and it is from the north pole. Velocity 2 will have a bearing of 210 degrees. So again, you measure it from the North Pole. All right. This is used in navigation of planes and ships, and therefore we will always measure it from the North Pole, that is 0 degrees. So the third way is the direction of a vector relative to another vector. So how will we do that? So we have vector A and vector B, and they can be in different directions, as you can see here. Vector A and vector B, and the angle will be from A to B. All right, so in each of the above cases, vector A is at 30 degrees to vector B. So very important is the direction of the vector is always measured at the tail of the vector. The direction of the vector is always measured at the tail of the vector. So you will say it is A, in each of the above cases, vector A is at 30 degrees to vector B. So you will say 30 degrees from vector B. All right, so what do we have here? The graphical representation of a vector. Any vector can be represented by an arrow drawn to scale with the arrow head, as I indicated here. There's the magnitude. The direction of the head is an arrow, and the region is the tail. You start from the tail, so the angle that we do have here is the direction. So 10 meter due east can thus be represented as follows. All right, 10 meter east, we have the magnitude, the unit, and the direction, and this is a drawn to according to a certain scale. So I draw this 1 centimeter is 1 meter. So therefore, if you have 10 meters, it is 10 meters east, 10 meters, the magnitude is 10, the unit is meter, and the direction is east. So now, what do we have here? The net or resultant vector. What is a net or resultant vector? The resultant is the single vector that will have the same effect as the original vectors taken together. We have two forces here, a 10 Newton and a 20 Newton vectors, a 10 Newton and 20 Newton, and both of them are in the left direction, or we can say it is west. So when we add, you just add them together and we have a 30 Newton west, or 30 Newton to the left. All right, so the force that are applied are to the left. All right, here we have a 6 Newton force to the left and 12 Newton force to the right. So they are in opposite directions. So the moment they are in opposite directions, you add them together, you will have the resultant force of 6 Newton, because the one is to the left and the other one is to the right, and the resultant force will therefore be 6 newtons to the right. All right, so that both of them are the resultant vector. So it's moving. The top one, I'm not sure. The moment when I saved it. So just make sure it's just for the below one. All right, so the addition of vectors. If we look then at vectors, two different vectors, we can say velocity 1 is 10 meters east, velocity 2 is 15 meters east. So your resultant will therefore be 25 meters east. Here we have 15 meters west, 5 meters east. So your resultant is therefore 10 meters to the west. So addition of vectors can be in the same direction. So as we have here, a man walks 10 meters east and then a further 10 meters east. So you add them together. So you'll find the resultant displacement. Now it is displacement because we have direction, we apply direction to it. So when vectors are in the opposite direction, a dog walks 15 meters west and then 5 meters east. Find its resultant displacement. Therefore, again, if you add it together, it will be 10 meters to the west. All right, so I hope you are still with me. All right, so this is vectors in a straight line. We say it is linear. It is linear. So linear is in a straight line vectors. So in grade 10, we just use linear. All right. So here we have triangle method. I'm just going to go quickly through this because this are the addition of vectors. These are the addition of vectors that you're going to do in grade 11 and 12 as well, if they are in different directions. These are 2 dimensions, so this is not part of your grade 10 work, but make sure that you do use this next year as well. I'm just included in here so that you can be aware of that there are different ways. The only one that you do in grade 10 is therefore the linear method, the triangle method, the parallelogram method, the polygon method are methods that you're going to use in grade 11 and 12. All right. So now, the next one is movement in one dimension, as I state the next topic. So as I stated in the previous slide, it is just movement in one direction. So it can be either to the left, to the right. So we are looking at displacement, velocity, time, and acceleration in movement in one dimension. So the areas that I'm going to cover this morning in one dimension is position, movement in one dimension, distance and displacement, speed and velocity, acceleration. So if we look at position, what is position? Position of an object must be defined in relation to some standard reference point. So this means that you pick a point, any point, and every movement is measured from that point. All right, in a positive or a negative direction. So here you can see you have Alex's house. Alex moved from his house to his friend's, from his house, and is moving from, or he drives 12 minus 3 drive 9 kilometers. Okay, if he started to drive from Amy's house or the city hall, the distance will be different. All right, so if he's driving from the city hall west, then it is in a negative direction. But if he's driving from the city hall to his house and further on, it is in a positive direction, and we say it's east or west, you can both directions. All right, so what is position then? We have position is the place where an object is relative to a reference point. So the boy is standing still in a train, and the train is moving from the left to the right. So from your frame of reference, the boy is moving, therefore, from the left. Here is you are standing here on a platform, and that is the reference point or origin. You standing still. The train is moving, the boy is standing still. So the position of the boy is the point where an object is relative to the reference point, and you are the reference point. The reference point is therefore from which the position of an object is measured. All right. So the reference point of P is the abbreviation for reference point, and the reference point does not move. So this is your reference point. You're looking at the boy, and the train is moving. And when you look at the boy, you will see it's as if he is moving as well, but he is standing still. So from your frame of reference, the boy is moving from the left to the right. So negative direction will be to the left, positive direction will be to the right. So a boy inside the train, which is moving from left to right, so it looks as if he is moving in a positive direction, although he's standing still in the train. All right, but the train is moving in a positive direction. So what is movement in one dimension? Movement in one dimension is movement along a straight line. As I show you the different movements that we can have, that you will do in grade 11 and 12. So movement in one dimension will be in a straight line. That is what you're going to cover in grade 10. A description of motion relates to position and time. So you must be able to answer questions about movement in one direction. So in the figure below, for example, this will be a scenario. In the figure below, the car has moved from point A to point B in a specific time period. That is movement in one direction. All right. So we're going to look at the definitions of distance. What is distance then? Distance is the actual distance or path length covered by an object. The displacement is the magnitude and direction of a straight line drawn from the starting point to the end point of motion. That is your displacement. You are moving, or you are driving around in the estate this morning. That will be your distance. Say, for example, you drove 5 kilometers, but it's not in a straight line. Then that will be the distance you covered. Okay. So, but if we say as the bird flew, that will be the displacement. It's from the direction from a straight line drawn from the starting point to the end point. So the next thing then is, let us just look at an example. So here we have the distance covered and the displacement from A to B. So the straight line AB is the displacement, say 20 meters due east. The dotted line AB is the distance or path length actually taken to get from point A to point B as you drive in the estate around 5 kilometers. But say, for example, this is your distance then, and that is the straight line will be the displacement. So the dotted line is in no specific direction. So this is the difference between displacement and distance. All right, speed and velocity. Speed is the rate of change of distance. Speed, therefore, is distance divided by time. And the symbol for speed is V. The symbol for distance is a capital letter D. And the time is the delta t, and the unit for speed is therefore meters per second. Velocity, on the other hand, is the rate of change of displacement, or we say displacement divided by time. So velocity is displacement divided by time. And the arrow that we have here on top of the small letter v is a vector is written with an arrow to differentiate from a scalar, to differentiate it from a scalar, and it's the same thing. The distance is now delta x, or if it's a vertical displacement, it will be in a delta y direction. But for a horizontal displacement, as we have this here, it is delta x, and the time therefore again will be delta t, and the unit again is in meters per second, but you have to include direction because it is a vector. All right, so you will see that the velocity will not be necessarily the same as the speed because of the displacement that will be different than the distance. All right, so adding velocity vectors, always assign a positive direction when we add. Always assign a positive direction when we working with vectors. All right. So a swimmer can swim at 2 meters per second and swims downstream in a river flowing at 3 meters per second due east. Find his resultant. So a swimmer swims at 2 meters per second downstream in a river flowing at 3 meters per second. All right. So what will be the resultant velocity? The resultant velocity will therefore be 5 meters per second east. So what is the resultant velocity if he swims upstream? So again, upstream, so again, the river flow 3 meters per second east. You are swimming 2 meters per second west. This is the meaning for upstream. So the resultant will therefore then be 1 meters per second east. All right. So the direction that we do have here to the right, it's the positive direction. If we look at our calculations, you will see that to the right is positive and to the left is negative. And the difference between the two of them to get to the resultant is you add them together to have 5 meters per second east. If you add them together to the east and to the west, you will have 1 meters per second east. All right. So east is therefore positive, or you can either show it as east is positive. You must state before you start doing or adding the velocity vectors together, you must state that you have east as positive and to the right as positive. So what is acceleration? All right. Acceleration is the rate of change of velocity. So we have a final velocity, we have an initial velocity, and we have change. That are the three terms that we're looking at when we look at acceleration of an object. All right, so it is the rate of change of velocity of an object. So acceleration is the change of velocity divided by time. So if we look at the symbols, acceleration is A, change of velocity is a change is the delta, the triangle in front of the V is change of velocity, it's a vector, so therefore the arrow on top of it, and change in time. So now, what is change in velocity? The symbol for change in velocity is v final minus v initial. Change in time is delta t, so that will also be t1, t final minus t initial, and therefore the unit for acceleration will be meters per second squared. Why meters per second squared? It will be meters per second squared because the unit for velocity is meters per second and the unit for time is time. So if we have meters per second divided by second, then we have meters per second squared. All right, the minus 2 is of the 2 of that we do have below. So you have a direction. We only deal with problems with constant uniform acceleration. Very important. We only deal with problems with constant uniform acceleration. So what do we have here? Also direction of acceleration. I do have two scenarios here. All right. So if we have acceleration of an object in the same direction as its velocity, the object's velocity increases. So here you can see acceleration is driving faster to the right, and its velocity, so both the acceleration and the velocity is in the same direction. So therefore the velocity will be, the velocity and the direction are both in the same direction. So therefore you will have that the object's velocity increases. All right. So if we have velocity and acceleration in the negative direction, you will see both of them are in the same direction again, so the velocity will increase. So if the acceleration of an object is in opposite direction as its velocity, so therefore it is driving, there's a stop street, you're driving from the stop street, you will see that, or you're driving slower because you're driving to the stop street, the sign, you're driving to it, you will driving slower, so therefore your acceleration will be in a negative direction. So therefore the velocity will decreases. It can be to the right or to the left. Your velocity, if the acceleration is the acceleration and the velocity are in opposite directions, you will find that your the velocity of the object decreases. All right, so you will deal with ticker type problems. Ticker type problems is calculating acceleration from ticker type information. So what is a ticker tape? A ticker tape is a piece of tape with dots on it. So the direction of the movement of the trolley that the ticker tape is attached to will be to the left. And you will see that the ticker tape is attached to a ticker that makes dots on the ticker on the tape. So therefore, you can see here the dots that are the dots are further apart from each other. They are different lengths here. So here we have what the period then. The period is the time between the successive dots. So in other words, between A and B, that is the time that it takes. So between A and B, can you see it's 5 millimeters, and from D you will see it's 12 millimeters. All right. So the velocity, its instantaneous velocity midway in time will be the velocity between A and B will be instantaneous velocity midway in time. So if we do have to calculate the period, you will see the frequency. You already work with frequency when you do sound waves. You did the calculations for period, so this is not new terms to you. So the frequency is for the ticker tape is 50 hertz, and if you have to calculate the period that it takes, the time that it takes from dot A to dot B, you calculate it with your formula. T equals 1 divided by frequency, 1 divided by 50. So the period between dot A and dot B is 0,02 seconds. All right, so the ticker tape problem do have, if you have to calculate it, you will see that is, you have distance between A and B. The distance between C and D is the 12 millimeters. It just shift to the right. So if you have to calculate it, you will see the distance for AB will be 0,05. The velocity, to calculate the velocity or the speed. So you have 0,05 divided by 0,02, that's the time taken. So the average velocity between A and B is therefore 0,25 meters per second, and the average between C and D is 0,16 meters per second. So what will the acceleration then be? It is the difference between velocity 1 and velocity 2 divided by the time for these two time slots, and therefore that will be 8,75 meters per second. Again, you calculate the time for each period. You calculate the period by using the formula T equals 1 divided by frequency. All right, so you will work with 3 different types of ticker tapes. Uniform or constant velocity. What is uniform or constant velocity? If the ticker tape or the trolley moves at a constant velocity, you will see all the dots, the distance or the displacement between the dots are the same, the distance between the dots are the same. If it's a positive acceleration, you will see the direction of movement. In all 3 scenarios, it is the same. You can see to the left, the direction is to the left. If it's a positive acceleration, the dots will be further apart. And if it's a negative acceleration, the dots will move closer to each other. All right. Again, I include the additional resources for physical sciences. So if it's for the learners that attend this session for the first time, it is resources that are available. Impact using Doxai Hensha's textbooks. So Doxai Hensha's textbooks are books that you can order from them, and we use their study guides, and in their study guides there are summaries, mind maps, and the question papers are available at Impact, and we make it available on our Impact online platform as well. Exercise books you can order from them. There is the website where you can order it from, and past papers you can also download some of it. You can download from the website. the others you can buy from the from this store of them. Right. So the next one is the Quanta books. I will change this slide for a new one. Replace it so that you can see it better. All right, so this is Quanta books. That's how the Quanta books. That's part of Impact's Physical Sciences package for the term for the year. That's very useful and excellent lessons on DVDs. The DVDs are at the back of the Quanta books. So impact learners, if you did see, or if you see the Quanta books but you didn't start to use it at this point, start using it because it's very useful. There are summaries in it with exam type of questions, but the most important thing are the DVDs that are at the back of the Quanta book. If there are any concepts that you don't understand, you can look at the lesson. It's really not long lessons. It's like 10 maybe 10 minutes per lesson. The basic concepts of physics and chemistry explained on the DVDs with animations, some of them with animations or video links. And then the most important thing is the exam type of questions that you have to use for preparing for the exams, and the memorandums are at the back of the Quanta books. So make sure that you mark your questions the moment after you work through the questions. Mark the questions. The multiple choice questions are also very important because they explain the multiple choice questions. Why is it A and not B, for example? So yes, you can also, if you're not an impact learner, you can order it from http order.quantabooks.co.za, or you can send us an email to impact to find out where you can order it. This is an example of the exam type of question that you can find in the Quanta book. All right, then the science clinic notes and exam seminars. The science clinic notes are the ones that you can see here. They are very useful summaries that you can download for free from the website, the Science Clinic website. You can download it from scienceclinic.co.za books. You can see the links here below. So please make sure that you download the Smart Prep books with the summaries. There are also explanations and examples of questions there. And the exam seminars, you can register now. They do have exam seminars for the rest of the year. Go on their website, scienceclinic.co.za, and see where there are different venues. But please, if you are an impact learner, click on the link and you will see that at the school you have to choose from. Choose impact centers near you. You just start and write an impact and look at choose an impact center near you. Or the reason for that is if you register with the impact and state that you are from impact, you can get some discount if you register soon enough. Okay, but you can also send them an email. Right. If you do have any questions, send me an email to academics@impact.co.za for attention Marie Kotze, or you can, if you're not registered with Impact, you can contact us at impact.co.za. Thank you very much for attending today's lesson. I hope you find it useful, and yes, and good luck with all your preparation that you are busy with at this stage for the June exam that you're going to write from the 1st of July. So, and make sure if you do have any questions, send me an email. Have a nice day. Bye.